Let us find the roots of the quadratic equation of 10x squared minus x minus 3 is equal to 0. Okay. Now, using the formula for the roots, x is equal to 1 plus or minus square root of 1 plus 120 by 20. Okay, so we get this as 1 plus or minus 11 by 20, which is the roots we get as roots are 3 by 5 and minus 1 by 2. Okay, so these are the roots. Now, alternatively, we may use the method of a factorization. So that is 10x squared minus x minus 3 is equal to 0, which is equal to 10x squared minus 6x plus 5 minus 3. Okay, since 10 multiplied by minus 3, which is 30, and which is 30, and also minus 6 is multiplied with 5. Okay, that also results 30. Okay, so we have that is minus 6 plus 5 is minus 1. Okay, so which is equal to 2x into 5x minus 3 plus 1 multiplied 5x minus 3. Okay, so which is equal to 2x plus 1 and 5x minus 3. Fine. So we get again the roots are minus 1 by 2 and 3 by 5. Okay, so let's see the next problem to find the equation whose roots are minus 1 and 3 by 4. Now, if we consider alpha and beta are the roots of the quadratic equation, then the quadratic equation is given by x squared minus the sum of the roots into x plus product of the roots, which is equal to 0. So this implies that x squared minus this is sum of the roots, which is minus 1 by 2 plus 3 by 4, right, into x plus the product, that is 1 by 2 multiplied 3 by 4. Okay, so which is equal to 0. Now or this can be further written as x squared minus 1 by 4x minus 3 by 8 is equal to 0. Okay, so this implies 8x squared minus 2x minus 3 is equal to 0. Okay, so this is the quadratic equation given the roots as minus half and 3 by 4. Okay, so let us look at the next problem. If alpha and beta are the roots of the quadratic equation ax squared plus bx plus c is equal to 0, then let us find the expression for alpha square minus beta square in the terms of a comma b comma c. Okay, so we know that alpha plus beta is equal to the sum of the roots, okay, that is minus b by a, and alpha into beta, the product of the roots, the product of the roots is c by a. Okay, now the required expression, okay, the required expression is alpha square minus beta square, okay, which is alpha minus beta, alpha plus beta. Okay, so which is minus b by a plus or minus square root of alpha plus beta whole square minus 4 alpha beta. Okay, this is equal to plus or minus b by a, this is square root of minus b by a whole square minus 4c by a. Okay, when we simplify this further, so this will be equal to plus or minus b by a square square root of b square minus 4ac. Yeah, let us look at the problem. Now if alpha and beta are the roots of the quadratic equation ax squared plus bx plus c is equal to 0, where a is not equal to 0 and c is not equal to 0, form the equation whose roots are 1 by alpha and 1 by beta. So we have alpha plus beta is equal to minus b by a, and alpha into beta is c by a. Okay, so therefore 1 by alpha plus 1 by beta is equal to alpha plus beta by alpha into beta, okay, which is equal to minus b by a. And and 1 by alpha multiplied 1 by beta, which is equal to 1 by alpha into beta, which is C by A. Sorry, C by A here. Okay. This is I by C, right? Okay, and inverse A by C. Okay. The required equation that is x squared minus the sum of the roots to x plus the product of the roots, which is equal to 0. So that is x squared plus this is b by c into x plus a by c is equal to 0, or we can write as cx squared plus bx plus a is equal to 0. Okay, and let us have a look at another one. Now if alpha and beta are the roots of the equation, that is 5x squared plus 7x minus 3 is equal to 0, form the equation whose roots are alpha cube and beta cube. So we have alpha plus beta is equal to minus 7 by 5, and alpha into beta is minus 3 by 5. Okay. Now the sum of the roots of the equation, okay, of the equation, which is alpha cube plus beta cube, which is equal to alpha plus beta whole cube minus 3 alpha beta into alpha plus beta. Okay, so which results minus 7 by 5 whole cube minus 3 by 5 and minus 7 by 5. Okay, so which is equal to minus 658 by 125. Okay, so therefore the required equation is x squared plus 658 by 125 and minus 27 by, since the product is alpha into beta, right? This is 27, right? So 27 by 125, which is equal to 0. Okay, and or this can be also written as 125 x squared plus 658x minus 27 is equal to 0. Okay. Now, in order to study the nature of the roots of a quadratic equation, okay, so let us look at four equations using the formula of the roots, okay, with the example. So that is, if I consider 3x squared minus 14x minus 5 is equal to 0. So x is minus b plus or minus square root of b squared minus 4ac by 2a. So where a is 3, b is minus 14 and c is minus 5. So we get x as 14 plus or minus square root of 256 by 6. Okay, so you get x as a 5 or minus 1 by 3. Let us look at another example to study the nature of the roots of the quadratic equation. X squared minus 3x minus 7 is equal to 0. So the roots are given by x as 3 plus square root of 37 by 2 and 3 minus root 37 by 2. Okay, again let us look at another example to study the nature of the roots of the quadratic equation. So that is 9x squared minus 6x plus 1 is equal to 0. Okay, now the roots are given as x 1 by 3 and 1 by 3. Okay, and again to study the nature of the roots of the quadratic equation. So this is x squared plus 2x plus 2 is equal to 0, and the roots are given as x as minus 2 plus square root of minus 4 by 2 and minus 2 minus root minus 4 by 2. Okay, so on any analysis of the nature of the roots of the four equations, it can be seen that the nature of the roots or the equation depends on b squared minus 4ac. This quantity is known as discriminant. Okay, so okay, in the example 1 which you have seen here, the discriminant is a positive and a perfect square. Okay, so the positive and perfect square, and the square roots are real, distinct, and rational. Okay, and now in the second example, the discriminant is positive but not a perfect square. Okay, the roots are real, distinct, and irrational. Okay, now in this third example, the discriminant is 0, okay, and the roots are real and equal. The fourth example, the discriminant is negative and we come across wherein the roots involved, the negative number is involved here, okay. So the square root of a negative number, okay, is involved here, okay, and such number does not exist, okay, and we have to enlarge the real number system to accommodate such numbers of square root of a negative number. We call that as a complex number, okay, call this as complex numbers, okay, so we call it a complex number. So you might have seen that the roots are now which is square root of -1, which is I, okay, so which is in the form of x plus iy. Yeah.